Welcome back to some more geometry. We're talking about 3.2 angles and parallel lines. This is kind of a continuation of the last one because it's based off lots of the last things. If anything, everything that does in the last 3.2, we're talking about here, but we're going to talk about the postulates and theorems that go with them that you'll be using when we do proofs. Proofs aren't going away, y'all. We're still going to be doing our two-column proofs. So let's talk about first one. So corresponding angles, as we talked about earlier, corresponding angles are angles that exist in the same position as each other, just on a different set of lines. So for example, angle 1 will be corresponding to angle 3. Okay, they're corresponding. So that is true by definition. Doesn't has nothing to do with their equalness or anything. It just has to do that. Now, this postulate right here states that if we know that these lines are parallel lines, so they have these little arrow in them, parallel lines, and they're cut by transversal, then these corresponding angles are congruent. Remember, what's congruent means what? It's another way for same. They're the same angle, same value. So the same angle. That means they equal each other, their value. The actual numerical number will be value. Now, though, 1 and 3 may be corresponding. So that means also then 1 and 7, they're equal to each other because they're what? They're vertical angles. Don't forget that. Vertical angles. And vertical angles always equal each other. Well, 7 also correspond to which angle? 5 down here. Yeah. That's why I kind of color code them like this. 1 and 7 are equal because of vertical angles. 1 and 3 are equals because they're corresponding angles. 3 and 5 are equal because of vertical angles, and 7 and 5 are equal. And same thing with the 2 and the 4, 8 and the 6. They're corresponding angles, so they are congruent to each other. They equal each other. So this is a postulate, meaning this is understood as fact. We kind of use this postulate to base a lot of the other things that are coming up next. So let's kind of look at this. Our next theorem is alternate interior angles. Again, as we talked about, we have two parallel lines right here. Alternate interior angles mean they're opposite sides of the transversal, but they're not next to each other. So to be interior means to be in between these two parallel lines, and then alternate interior angles will be 1 and 3, 2 and 4. And here's the thing. I don't know if you've picked up on this by now. These arcs, if they share the same one arc, that means they are equal to each other. If they share two arcs right here, that means those two are equal to each other. So they won't always color coordinate them like I do. They just gonna do this, or they'll do an arc with a low line, and then another arc with two lines, another arc with two lines, or they'll double arc it like this right here. Okay, so be mindful of that. Be looking for that. All right, so it's saying that if you have two parallel lines cut by a transversal, then these alternate interior angles are congruent. That means their value is the same. Congruent, equal, congruent. This is the congruent sign right here, by the way. Equals with the little squiggly above. This is an equal sign. There is a difference, and then as far as congruency means they're exactly the same. Without knowing the value, equal means their value is the same. Look at the next one, consecutive interior angles. So two angles cut by the transversal, then the same side interior angles are supplementary. Let's talk about supplementary. Supplementary means that one angle, we'll say angle A plus angle B, they're equal what? 180. We don't know their exact angles value, but then we know together they equal 180. That's very important. So in this case, angle 1 right here and angle 2 right here, they're supplementary. They're same side interior angles and they're supplementary. Angle 4 over here and angle 1.3 right here, they're same side interior angles, so they're supplementary to each other. It's still true, 1 and 3 are alternate interior angles and 2 and 4 are alternate interior angles, but we're talking about these particular angles. These two right here together and these two right here together. They're supplementary to each other. All right, let's look at the next one. Alternate exterior angles, very similar to the last one. There we have two parallel lines cut by transversal, alternate, so they're opposite sides transversal, and their exterior angles. They're congruent to each other. Angle 1, angle 3, angle 2, and angle 4. Okay, those are congruent to each other. Congruent, that means they're equal to each other. I think that's the last one of these Yeah, these names that we talked about. All right, so hopefully that kind of helps then see value when we start putting numbers with this. All right, so if a transversal is perpendicular to just one of these lines, so if we know these two lines are parallel, so it's saying, hey, you have parallel lines. We know for sure this transversal is perpendicular to the top one. Well, then by this theorem, it has to be perpendicular to the one because these two are parallel, means they're running in the same manner. They're angled in the same way. So they're being cut by one. If one line is parallel to the other, perpendicular to the other one, it has to be perpendicular to the other one by definition because the type of lines these two are and what the transversals do with one of them. It does with the other one. All right, so let's look at this. You'll see some questions very similar like this. So this is what we know. We're going to find the measure of these angles and the theorem that supports our answers. The theorem supports our answers. So why we know that's for sure. So what we know is that the line X and line Y are parallel, and N and Q are parallel to each other. So single to single, that means these are parallel to each other. Double to double, these are parallel to each other. We know that angle 7 right here is 125. Okay, and then we know that X and Y are parallel. That's what these double lines right here means. They're parallel to each other. And N and Q are parallel to each other. Let's find these values. So let's look at angle 15. We'll start at 15. So 7 and 15, what will 15 be? Yeah, be 125. Why? What is 15's relationship to 7 right here? They're corresponding angles. Corresponding angles. Okay, angle 1 right here. What's 1? What will be the value of 1 right here? This will also be 125. Interesting. Why? What's 1 and 7's relationship to each other? The vertical angles. Good. Let's look at angle 3. Excuse me. 7 and 3 right here. So 7, 3's relation to 7. What would 3 be? Also be 125. What would be 125? They're alternate interior angles. Interior angles. Wow. We're looking because 7 and 3, we treat X as a transversal, and then these two the parallel lines. So that means 2, 7, 3, and 6 are interior angles. So they're alternate, opposite side of the transversal, and they're both interior angles. Good, 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 good. Let's look at 5. Angle 5. What is 5's relationship to 7 over here? What will be the value of 5? It will also be 125. Good. What's 7 and 5's relationship to each other? Yeah, they're corresponding angles. Corresponding angles. Good. And angle 6 right here. Well, they're relationship to each other. This X will be the transversal, N and Q will be the parallel lines. They're both interior angles and they're both on the same side. So they'll be supplementary. So since they're supplementary, because as we said, they're consecutive interior angles, that makes this 55 degrees because they're consecutive interior angles. All right. Hopefully that helps out, y'all. Have a great day.